Hello students, today we will do chapter 10 circles, and this is the second theorem of this chapter, which is again a very important theorem and will give you very important result. And this theorem states that length of two tangents from an exterior point to a circle are equal. So children, here we are given a circle whose center is O and radius is R. So to represent this thing, to write this thing, that we are given a circle with center O and radius R, we note it down like this. C stands for circle, O is the center and R is the radius. So we will read it as circle with center O and radius R is given to us. Also we are given two tangents from an exterior point P. From this point P we are given two tangents, PA and PB, and we need to prove that this length of these tangents are equal, that is PA is equal to PB. So we are to prove that PA and PB are equal in length. Listen children, the length of the tangent is always measured from this exterior point till the point of contact only. So if I ask what is the length of this tangent, you will measure from P to A. And what is the length of this tangent? So you will measure from the exterior point to the point of contact, that is PB. So we need to prove that PA is equal to PB. Now to prove this, we will do construction, that is we will join OP, we will join OA and OB, and now clearly visible that in this figure we have two triangles, and let's prove that these two triangles are congruent. So we have triangle PAO and triangle PBO. Angle 1 is equal to angle 2 because this is the radius and this is the tangent, and yesterday in theorem 1 we have read that radius is always perpendicular to tangent at point of contact. So using that theorem, angle 1 and angle 2 both are equal to 90 degree, as this is radius and this is the tangent, and at point of contact radius is always perpendicular to tangent. So angle 1 and angle 2 are equal, radius perpendicular to the tangent at point of contact. Now OP is the common side between the two triangles. So OP is equal to OP common, and OA and OB both are the radii of the same circle. So OA and OB are also equal, and therefore these two triangles are congruent by right angle and side opposite to right angle, that is hypot, which was the common side. So that is also equal, right angle hypot, and one of the side of both the triangles OA and OB are equal. So we can say that the triangles are congruent by RHS, and if the triangles are congruent we can say that PA is equal to PB, that is by CP CT, corresponding parts of congruent triangle. Now children, using this theorem we have proved that these two triangles are congruent. If these two triangles are congruent by CPCT only, we will get this result that angle 1 and angle 2 both are equal. Angle 1 and angle 2 are equal. Therefore we derive few very important results. So here we can write that we are getting very important result by proving these two triangles congruent. So very important results. What are they? Now children, these results are the tangent lines. The tangent lines are making equal angle with this line OP. So we can say that tangents from exterior point are equally inclined. Equally inclined means they are making equal angles to the line joining exterior point and the center. Tangents are equally inclined to the line joining exterior point and the center of the circle. Similarly, if the triangles are congruent, we can say angle 3 and angle 4 are also equal, and if angle 3 and angle 4 are equal, we can say these radii are also equally inclined to the line joining center and the exterior point. Also children, listen, let's see this triangle, this figure. In this figure, you have proved that PA is equal to PB. You have seen that this angle is equal to this angle, and also you are able to see that PM is the common side between these two triangles PAM and PBM. So we can say that these two triangles are also congruent, and if these two triangles are congruent, we can say angle 3 and angle 4 are equal, and since they are making linear pair, so we can say that these two angles are of 90 degree each. So we can say that this line OP is perpendicular to AB, and since we have proved these two triangles are congruent, children, so we can say that AM is equal to BM. So with this, again we got a very important result that OP is the perpendicular bisector of the chord AB. So this question can also come in your exam to prove that OP always bisects the chord formed by joining the 2 points of contact. So that means OP is perpendicular bisector of the chord AB. So what you need to do, you have to prove triangle PAM and triangle PBM, they are congruent. And now children, if you have seen this angle A and angle B, they are always 90 degree angles since radius is perpendicular to tangent. Therefore, children, this is a quadrilateral, and you have seen that the opposite angles, one pair of opposite angle is giving us sum equal to 180 degree. The sum of all the 4 angles is 360 degree. That shows that the remaining 2 angles are also equal to 180 degree. Therefore, we can say that this quadrilateral is always a cyclic quadrilateral, because sum of both the opposite angles of cyclic quadrilateral is equal to 180 degree. So angle 1, this angle A and angle B is 90 degree each. That means the sum of the opposite angles of the quadrilateral is equal to 180 degree. Therefore, we can say that PAOB is a cyclic quadrilateral, and angle 1 plus angle 2 is always equal to 180 degree. That's all for today, children. Keep working hard.